Good morning, students. Today, in grade 9 science, we are going to discuss about derived units. And you all know derived units are those units which are used to express um, the derived quantities, and they usually depend on two or more fundamental units. Two or more fundamental units. Okay, if you remember what is fundamental units from grade 8, fundamental units are those units which are independent on any other units, and they are used to measure, they are used to express the fundamental quantities. And if you remember, this fundamental quantities can be measured directly, whereas derived quantities cannot be measured directly. And some of the examples of derived quantities are speed. For example, let's say if you need to measure speed of an object, then you need to measure first the distance covered by the object in particular time, like a distance covered, and then you need to measure time taken to cover that distance, and then you can calculate speed by dividing total distance covered divided by time, and that way you can find out distance covered in 1 second time or unit time. And hence, to measure speed, you need to measure two other quantities, distance and time. That means speed is dependent on distance and time. So speed is derived quantity, whereas distance and time are fundamental quantity. Get me to another example, and that is of volume. Volume, you need to measure volume of an object, a regular object. You need to measure length, its breadth, and its height. Length, breadth, and height, all of them are distance, or all of them are distance. Okay, so after measuring these three parameters, you can find out volume by multiplying all them, L into B into S, then you get volume. So you can see volume is dependent on three other fundamental quantities. Three other quantities, they are distance. Okay, so volume is derived quantity, whereas length, breadth, and height or distance is fundamental quantity. Similarly, to get to another example, density. Okay, if you remember, density is defined as mass per unit volume. So to measure density, first you need to find out mass of an object, and then you need to find out volume of that object. So to measure volume, once again you need to find out length, breadth, and height. Only then you can calculate density as mass divided by volume. So you can say density depends on not just two, but it depends on four other quantities. So density is derived quantity, whereas mass and length or distance, they are fundamental quantities. So by this much, I hope you understand what are derived units. And today in grade 9, according to your syllabus, we need to mathematically show that derived units of derived quantities can be obtained from fundamental quantities. Okay, that means in other way, this is the relationship between fundamental and derived quantities. Okay, a number first of all, I'd like to go to area. As you all know, if we need to define area, what is area? Then you can say that area is amount of surface occupied by a flat object. That means area is two-dimensional feature. And mathematically, area of a regular object can be calculated by the formula length into breadth. Now, as you know, since those length and breadth, both length and breadth are fundamental quantities, now we can go to unit, taking unit of all terms. What you get, unit of area, we still don't know unit of area. We presume that we still don't know unit of area. Now unit of area, and we don't know, and unit of length is meter, and again unit of breadth is meter. So through this we get meter square. So since you can see that unit of area depends on two fundamental units. You can see unit of area depends on two fundamental units, and they are meter and meter. You can see two fundamental units, meter and meter, are involved in forming unit of area. So you can say it is derived unit. I hope there is no confusion in it. Say it once again. If you cannot read it through the screen, then take a screenshot and copy it in your note copy. That will be beneficial for you, because not just listening and reading is the way to learn, but writing it several times is also the best way to learn it. Okay, now let's go to number 2. After area, we are going to discuss about volume. And you know what is volume? Volume is the amount of space taken by an object, and volume is three-dimensional feature, a three-dimensional phenomenon. Volume of an object is defined as the amount of space taken by an object in 3 dimensions. So mathematically, you know how is volume calculated? Volume of a regular object calculated mathematically. You know, it is volume is equals to length into breadth into height. And we know that all those terms, length, breadth and height, all those terms are fundamental quantities. So at this stage we can take unit of each term. Taking unit of all terms, which you get unit of volume. Presumably we do not know the unit of volume yet. Unit of volume we don't know. Unit of length is meter, unit of breadth is meter, and unit of height is also meter, and it gives us meter cube. So you can see that unit of volume depends on 3 other fundamental units. So you get conclusion, unit of volume depends on 3 fundamental units, and that is meter, meter and meter. You can say 3 fundamental units, meter, are included in expressing unit of volume. So you can say that it is derived unit. It means unit of volume is derived unit. So once again, you can capture the screen. You can take screenshot and copy it several times to practice it. Okay, now let's go to next number 3. After area and volume, I want to go through number 3, density. Okay, if you remember, what is density? Density is defined as mass per unit volume, or in another word, density gives the idea of how heavy of an object. Okay, like iron, among iron and wood, which one is heavier? If I ask you, surely you would say iron is heavier than wood. And in scientific term, iron has more density than wood. And if we take exactly 1 meter cube volume of iron and 1 meter cube volume of wood, then it is obvious that iron would be much more heavier than wood. And to say wood is around 400 an average 400 kilogram. If you take 1 meter cube of wood, then it would weigh approximately 400 kilogram, whereas iron, it might take about 7,800 kilogram. Per cubic meter of iron might weigh up to 7,800 kilogram, whereas the same volume of wood weighs only contains only 400 kg of mass. That means in particular volume of iron and wood, iron contains more mass than wood. That's why iron is heavier than wood. Okay, so density measures how heavy an object is. It compares the heaviness of an object. Okay, anyway, come to mathematical expression. Mathematically, you can see density is defined as mass per unit volume. Density is defined as mass per unit volume. And here you can see mass is fundamental quantity, but volume is not a fundamental quantity, and you need to express volume in terms of fundamental quantities. So it would be mass per length per breadth per height. Mass divided by length, breadth and height. Now you can see all those four terms are fundamental quantities. Now at this stage you can take unit, taking units of all terms. Taking units of all terms, what you get, and presumably we still don't know what is the unit of density, so I'll simply write unit of density. Unit of density is equals to, now unit of mass is kg, unit of length is meter, unit of breadth is meter, and again unit of height is also meter. So it finally gives kg/meter cube. So you can see unit of density is kg/meter cube. And here in this conclusion you can also see that it depends on 4 other fundamental units. That's why unit of density is derived unit. Now give conclusion. Since unit of density depends on 4 fundamental units, that is kg, meter, meter and meter, it is derived unit. Okay, I hope up to here there is no confusion. If you need, I suggest you to take a capture screen, take screenshot of this and write it several times, repeat it several times until you can write it whole on your own without taking any assistance. Okay, now next I'll go to number 4, and number 4, it is velocity. Velocity or speed, both have same unit if you are curious. Velocity, the only difference is velocity is vector quantity, whereas speed is scalar quantity. That means velocity contains magnitude as well as direction, whereas speed contains only magnitude. And now to define velocity, we know how fast an object is moving, that is defined as speed, and how fast an object is moving in particular direction, that is defined as velocity. So you can say speed or velocity, they can be defined as distance traveled by an object per unit time. Distance traveled by an object per unit time is known as speed. Okay, here let's see, speed equals to distance traveled by an object per unit time. Okay, note here we are not talking about any direction. In whichever direction it moves, it does not matter. Whereas velocity is defined as distance traveled by an object, same as above, per unit time in particular direction. That means if an object changes its direction of movement, then its velocity also changes. So distance traveled in particular direction is also known as displacement. So you can say our velocity is defined as displacement made by an object, per unit time. So speed is defined as distance traveled by an object per unit time, whereas velocity is defined as displacement made by an object per unit time. And distance and displacement both have same unit. Once again, distance and displacement, they are the only difference between distance and displacement is distance is scalar quantity, whereas displacement is vector quantity. Now let's continue. Mathematically, velocity is defined as displacement made by an object divided by time taken. Displacement by time. And now you can see both displacement and time, they are fundamental quantities. So at this stage you can take unit. Taking unit of all terms. Once again, we presume that we do not know the unit of velocity. So we simply write unit of velocity is equals to unit of displacement is meter and unit of time is second. So unit of velocity, we get it meter per second. Unit of velocity is meter per second. And unit of speed is also same, meter per second. Now here you can see that unit of velocity depends on two other fundamental units, that is meter and second. You can say unit of velocity is derived unit. Now give conclusion. Since unit of velocity depends on two fundamental units and they are meter and second, you can say it is derived unit. Okay, the same procedure, by the same procedure you can also prove that unit of speed is also derived unit. Now the last one for today, we are going through acceleration. This is the last one for today, but not last in the lesson. We will continue the rest of the derived quantities. We will derive or we will determine the units of other derived quantities in tomorrow's lesson. Today this is the last one, acceleration. And you know what is acceleration? You have studied that in grade 8. Acceleration is defined as change in velocity per unit time. So if an object is moving with same velocity throughout the time, then acceleration of the object is 0. But in general, in our daily life, we cannot see any object that moves with same velocity. They keep on changing either in terms of magnitude or in terms of direction. So there is always change in velocity of an object, moving object in general, and in 1 second time, by what amount the velocity is being changed, that is called acceleration. So mathematically, acceleration is defined as final velocity minus initial velocity divided by time. V stands for final velocity and U stands for initial velocity divided by time. And we know time is a fundamental quantity, but velocity, both final velocity and initial velocity, they are not fundamental quantities. Or you can let's write it like this: change in velocity divided by time. Now since velocity is not a fundamental quantity, it is derived quantity, we need to express, or we need to reduce this term in fundamental quantities as well. We know velocity is defined, okay, I'll write it like this for simplicity: velocity into 1 upon time. It will make it simpler. Change in velocity divided by time, it can also be written as velocity into 1 upon time. Now we know that velocity is displacement made divided by time taken, displacement by time taken, and this 1 by time it remains as such. Now you can see all the terms are reduced to fundamental quantities. Displacement is fundamental quantity, time is fundamental quantity, and here time, once again time, it is fundamental quantity. Now at this stage we can take unit of all terms. Taking unit of all terms, what we get, unit of acceleration, we presume that we do not know it. Unit of acceleration is equals to, unit of distance displacement is meter, unit of time is second, and 1 divided at, once again unit of time is second, so it gives us meter slash second square, or meter per squared second. So it shows that unit of acceleration depends on 3 other fundamental quantities: meter, second, and second. That's why unit of acceleration is a derived unit. So let's give the conclusion. Since the unit of acceleration depends on 3 fundamental quantities, 3 fundamental units, and they are meter, second, and second, you can say it is derived unit. Okay, once again you might want to take the screenshot. Okay, take the screenshot and repeat it several times. Okay, so students, for today, this much lesson is for today. We will further continue remaining 5 derived quantities. Tomorrow we will continue this lesson. We will derive units of 5 other derived quantities, and these are force, work, power, pressure, and momentum. And what I want you to do today as your homework is, you have taken screenshot of all five derivations that we have done today. Yes, number 1 area, number 2 volume, number 3 density, okay, number 4 velocity or speed, it is here, okay, number 4 velocity, and number 5 acceleration. Take screenshot of all those 5 and practice. You need to practice them until you can write it fluently without taking any help. Okay, so I suggest you that you at least practice it 5 times, at least practice them 5 times, so that it will be very much fluent. Okay, that is your homework. Practice 5 times all those derivations. Thank you very much. We'll see you tomorrow.